In this video, we're going to evaluate the integral of 1 over the square root of x plus 2 minus the square root of x. So we got the difference of two radical expressions in the denominator. So we know that, the difference and the sum of the same two terms or expressions, a minus b times a plus b gives you a squared minus b squared. So if I multiply the denominator by the conjugate of what we have, in other words, we're going to rationalize the denominator, that'll give me the square of the first expression minus the square of the second one. And that'll eliminate the radical. So we're going to start off by doing this then. Got the square root of a plus 2. And the conjugate of this expression here is with a plus square root of x plus 2 plus the square root of x. Multiply the numerator in the denominator, or the denominator in the numerator, by this. And we can do that because all we're doing is multiplying by 1. So multiplying the integral by 1. Because notice, square root of x plus 2 plus the square root of x over the square root of x plus 2 plus the square root of x. That's just 1. Those divide out. So this is equal to then, in the denominator, or the numerator I should say, I'm going to have the square root of x plus 2 plus the square root of x. And this is dx. In the denominator, I have the difference in the sum of the same two terms, so that'll give me the square of this first radical, which is just give me x plus 2, minus the square of the second one. So we end up with this. So we have then x minus x cancels. That leaves me with a 2. Let me just cancel these then. I'm left with a 2. And then I'm going to bring out this 1/2 out in front. So let me put it out in front. Got a 1/2 right here then. So now that gives me this. Now I simply integrate. Now this is going to be no different than if you wanted to integrate. So you wanted to integrate the square root of x. You put this x to the 1/2. Done these before in other videos. So we add 1 to the exponent. We get x to the 3/2. And then you divide the coefficient by that value, we get 2/3. Now you can do the first one the same way. Let me just show you this. If you have the square root, in this case x plus 2, and you want to integrate that, just like the one I did over here on the right, dx. Notice if I try to use u substitution in this, I get let u equal to x plus 2, then du, derivative of x is 1, derivative of 2 is 0. So this would just give me du, gives me dx. So what does this give me here then? This is just the integral. X plus 2, that's your u. And it's the square root. I'm going to write it with the fractional exponent. Instead of square root of it, I have it to the 1/2 power. And then dx, and this is dx here, and du are the same, so this is du. And then if I integrate this, add 1 to the exponent there, that'll give me 3/2. And then divide the coefficient 1 by 3/2 is 2/3, plus your constant of integration. And the same thing over here, plus the constant of integration. And then go back to this one over here, I would just replace the u by what it's equal to, x plus 2. So it'd be x plus 2, 2/3, x plus 2 to the 3/2 power. And there you have it. So the point I'm trying to make here is if you got a radical, whether it's a square root, a cube root, a fifth root, if the radicand is just x, in other words, it's linear, first degree, coefficient of 1, and you're adding or subtracting some constant, let's just call it c. This is the same thing as integrating. If you have the x plus 2 to the square root of that, that's the way you would do it. If this were a cube root, again, if you let u equal the radicand, the dx and the du are going to be the same. So you don't have to use a u substitution in that case. So that's why if I come back over here, after rationalizing the denominator, so the 2 came from, this 1/2 here came from the 2 we had down here when we rationalized it. So here's the deal then. If it's the square root or the cube root or whatever, and this is x plus something, or x minus something, where that something is a constant, as long as the coefficient here is a 1, you're okay. It's just going to work. You can do it just like the square root of x. So here we do this again. You look at the square root of x plus 2 is to the 1/2 power. So you add 1 to the 1/2, I get 3/2. When you divide the coefficient here by 3/2, that gives me a 2/3. And then do the same thing with the square root of x. It's the same thing as x to the 1/2. Okay, just doing it over again just to make sure here. So at 1 to the 1/2, I get 3/2. Divide the 1 here, coefficient, by 3/2, I get 2/3. And then it's plus the constant of integration. And then if we multiply through by the 1/2 here, 1/2, and then this 2 cancel here, so I get a 1/3. X plus 2 to the 3/2. In the same way, the 1/2 multiplies to 2/3. The 2 cancels, gives me a 1/3 there. And we get x to the 3/2 power plus the constant of integration. So this would be your answer. We could do some factoring here. So the final answer then is 1/3 times x plus 2 to the, is that 3/2 here, plus 1/3 x to the 3/2 plus the constant of integration. Thanks for watching. We'll see you next time.